Welcome, audience. So, we are having a conversation on taming AI identities forms. This is just not just another agentic AI stuff, because we have been feeling that the Skynet issues from a long period of time, and feels like agentic AI is already running inside our system. But just like running bots and service accounts or ML agents in production, agentic AI is progressing in a very huge scale. So that's where we will be discussing the challenges because of it, which will be faced around. So yes, moving on. Uh, so just bit about me. I have decade years of experience in DevSecOps, ML security, and supply chain software security, moving around from mostly ML and moving into cyber security. I recently published a book on software supply chain security with AI, IoT, and application security in focus. You can check it out on Amazon and Springer. And I'm also contributing in Cloud Security Alliance and as a lead in OWASP Agentic AI supply chain chapter. So, and do run a couple of podcasts if you would like to check it out. So let's move on to the topic here. So let's start from the my own experience. I've been kind of starting with the broken pipeline and then start to defend them. So my topic is is about stopping next wave of AI driven chaoses. And AI agentic AI is specifically autonomous decision making, and non-human identities are any credential accounts that isn't human. So whoever has been working on any other organization, they might have already seen those MCP servers running around as NHI in our organization. And with scale, so security need to find a better way to track, govern these throughout the scale. So that's what the challenge become more and more difficult for us. So the scale is the main real thread as AI agents scale exponentially, one spawning to another, and most of the organizations are now deploying these agents over the year. And this the agent scale is also even more trickier when we are seeing that it has multifold increased for API connections and authorization request as compared to the humans, which kind of is our estimate is around 148x of number of requests coming around for these kind of requests. So this gives a huge picture which makes AI agent and machine account outnumbering human users. So that's where we have to start moving our management of identities to governing these digital ecosystem in in the digital environment itself. So that's where we will be focusing today as NHI explosion moves around from service to service authentication, relying on APIs, IoTs, and containers and ML pipelines. ML pipeline specifically needing a dedicated model identities. So these are, and specifically for container, these are very short-lived. So there are variety of these NHI, and we have to have various solution for that. And even recently, we have seen one of the attack, which specifically, if somehow you have heard about a Salesforce drift and sale loft attack, where the attacker targeted Salesforce by abusing OAuth token from third-party app that was drift and sale loft. So basically these tools, which are the third party tools, are given some automation access for email synchronization, chat integration, sales engagement. The problem arises around you have to have persistent and broad scoped OAuth access for these into Salesforce in this case. And once you have compromised those, it's open the door for a wide variety of data available. So that's where in that attack, the backdoor was created into customer data. So the main lesson for any practitioner will be to monitor this inventory through inventory as well as monitor all the NHIs in their environment. And that's what is becoming a huge attack surface for any attacker. So how we are different from how we are moving from traditional IAM, and where traditional IAM is failing is these we can pick up the limitations of that, like OAuth, as we discuss on Salesforce drift attack. OAuth is scoped too broad, and the trust is usually statically defined. So as with the agent, the context usually change over the time period. So that doesn't OAuth doesn't take it account, and for OAuth doesn't separate human versus agent identity. So that's the main disadvantage there. Similarly, for SAML, it's too slow and session based again. So and with the confused deputy problem, the agent often get to overprivileged and ignores the user, you ignore the precise user constraint and enable risky privilege misuse. So these kind of are the major limitations of our traditional IAM. Some of real attack scenarios are like account compromise cascade, tool squatting. Many of you might have heard about that. And then is orphan credential. These are the old token left behind and still active, which was one of the case in even Salesloft OAuth token, where it use the old tokens and exfiltrate the Salesforce data. So the next are the main key takeaways of this presentation will be IAM wasn't designed for scalable agents, and that's where the problem lies. And it doesn't identify NHI, and because it's kind of a blind spot for it, and it's becoming the largest unseen attack surface. So the fix need to be different. So it can be a decentralized auditable ID plus zero trust. We might have been hearing about zero trust, but zero trust was not applicable uh, on any other environment that much of. But with agent, I think zero trust can give a solution to extend user to every AI agent and their activities. So the Cloud Security Alliance paper of Agentic IAM does discuss this, how we can trace the agentic action to make it verifiable, traceable, and revocable. So that's where will see the new architecture of identity that have four components. First one is a rich agent identity, that is DID, which we call uh, decentralized identifiers, which will be having global unique cryptographic secure agent identifier. And then VCs, these are signed proof of authority, and basically a validator agent agent attribute and roles. And then ANS is kind of a registry, just like DNS for agents. And then zero knowledge proof, this is a compliance without data exposure. So zero trust, as we know, does require a continuous verification for every action, and if applied on agent, will be continuously validating and verifying on the action. So in the breach which we talk in initially, a single platform compromise exposing hundreds of tenants, that's where the granularity of the access boundary and the rapid cross remediation mechanism does help, and that's where this ZKP can help us to mitigate such attack. So the next one is the paradigm of auditing and forensic governance model, where again, three different components can work on. Immutable sign log, which similarly as we have in our supply chain of container security, for non-repudiation, and that that non-repudiation with DID and VC-backed lock to guarantee it. And then the end-to-end traceability: who, what, when, why the action was taken or any change was taken, that need to be tracked around. There are multiple thoughts on that, how to do it. It's, it's still going on, but we have to work around on that. There are a couple of solutions, which one of the main good solution is to track on the context of the prompt template and the action of the agent action log. So that's sometimes really helpful. And then we have to have a broad governance model to understand the agent, to track the agent life cycle for strong onboarding and revocation of the identities. So then the practical steps which enterprise can take is, first for all, you have to inventory all the NHIs across the system. Then again, the secret management is always useful. It's the old guard as usual. And then you're enabling your SIM logging for agents. And finally, you have to test it on DIDs and VCs. This is a new concept coming around in Agentic AI. We have to pilot it for in the test environment and see how it is able to track the rapid NHI growth across the environment. And based on that, you can then tweak the existing detection engineering. Then is the dynamic authorization. That's another solution which is very interesting, as static RBAC is not enough. As we have talked about, the role is itself is not defined. So apart from the system instruction, is the behavior is changed based on the learning the agent has been doing on the field. So that's why we have to have embed context, intent, and risk aware policies. And that's where GIT credentials are one of the solutions, which expires in 15 minutes and tie the credential to one task, can help us think of GIT as a use and throw gloves. So there are three different prioritized way of implementing GIT. First one is, as we talk about, temporary validity. Then is task specific access, where the release privilege action will be there for permission limited to single tool, which will be allowing a specific number of actions. And the third one will be even more granular and coupled, where each credential tied to a job plus the agent itself. So it's actually tightening your task related credential over the agent itself. Then is the cryptographically non-remediation, as we discussed in the last couple of few slides, that DID can also be used to identify agent, and the verifiable credential can be shown, can be used to scope the permission, and context hash and prevent the replay, and cryptographic signature can be used to prove the authenticity. Then how to implement the cryptographic accountability. So first we have to provision the unique key for each agent, register the DID in a trusted registry, as we have talked about ANS. So that's something which can be tested on. And then issue VC, the verifiable credential signed by the trusted authorities, sign every action of agent taken. So that's again a very useful concept, where the agent's private key can be used to digitally sign, audit log, and API logs, and include the context hash to prevent the replay and tampering. And then centralize the immutable log for SIM, and finally automating the anomaly alerts. That's flagging the invalid and missing suspicious cryptographic proofs, or maybe ZKPs as well. So that's something, that's a full workflow of implementing hands-on tips for that. Again, the recap of our architecture, DIDs, and we see that how we can make the global session management, ensuring the cross protocol session and sportsman. That's when we discuss here. And next one is IR. Of course, we have to have an active policy to mitigate the compromise agents. DID again can pinpoint the compromise agent and kill the session globally from your session management and enforce the cross protocol block for those agents which have been identified by DID validation failure and sign log enable clean forensic reconstruction. Finally, the recovery again will be done by the revocation of the credential, patching, and reissuing the identifiers. So again, you have to have in enterprise IA playbook covering the AI agents. So that's what we have to ask whether as an enterprise we do all of our enterprise does even have a IA playbook like that. Then the deployment models we can pick. So if for internal enterprise it's centralized is easy and but it does have a single point of failure. Decentralized is mostly useful for the uh, resilience and resilient system where we require a very critical infrastructure kind of ecosystem kind of stuff where but it's complex to implement. And the federator one is good for the industry network, and the hybrid is what is always required as always recommended. uh, Best mix and combine the model stand for efficiency and gradual phase by phase adaptation. So the guidance will be start from centralized internal deployment model and then move into a hybrid based on your external vendors and partners and third party vendors join in. So the industry examples are for financial services as it's really critical. GIT credential will be useful for trading bots, and in healthcare, HIPAA compliant verifiable credential or VCs will be very useful for the supply chain. The federated trust for provisions, which we discussed in the last slides. And then for cryptograph, for the critical infrastructure, hardware backed DIDs. These are very interesting as even we have seen it discussed in AI bombs where for hardware backed DIDs with emergency revocation is something which keeps the autonomous maintenance of agent resilience and responsive as well. So yeah, that's pretty much is the slides. And for the people who want to further discuss or read about it, I would totally recommend the paper of Ken Havan is Novel Zero Trust Identity Framework for Agentic AI. This does discuss a lot of concepts which we today discuss about. And the second one is a white paper for Agentic AI IAM, which is which does talk about specifically why traditional IAM fails as well as why we have to work on VCs and DIDs and how those can be employed. I was a contributor of this paper, and yeah, so that's pretty much it. Uh, Thank you. Basically, these these attacks are maybe seems like a very theoretical one, but these attacks are actually happening. You can read about Salesforce as well as NX build attackers, where it was another bot which was compromised, and that chatbot was in turn to work around to access credentials and stuff from the backend. So these attacks are really getting interesting as we are moving around. So basically the future of AI security will start with getting identity right, and if you can't identify it you cannot secure it. So that's what will leave you with. And yeah, until then, let's offline. Let me know if you have any questions or any specific references you want to. I would love to help. Thank you.